Hi everyone, this is Ashok Kadagala. In this class, we are going to learn about microcontroller boards. Did you ever wonder how the devices like cameras, washing machines, air conditioners, and even smartwatches work? Well, there is a common device in each of them which is called as microcontroller. You can consider microcontroller as a small computer on that particular device. If you take an example of smartwatch, there will be a tiny computer inside which is called as microcontroller board, which controls every operation that's going on in that device. Likewise, washing machine and also all the other devices which are only designed to perform single task. I'll give you more clarity in the coming topics. Right. So the first thing, fundamental thing, what is a microcontroller board? Coming to the analogy, microcontroller board can be referred as the brain of our project. No matter what the project you do or no matter what the device you develop, microcontroller board will always be the brain of that project or a device which has a capacity to control each and every operation or each and every thing that is happening on that particular project. That is the reason we considered microcontroller board as the brain of our project. Microcontroller is basically a small computer on chip. We know that. And it is only used for some specific tasks. You cannot use it for multiple tasks. For example, washing machine can only wash your clothes but cannot air condition your room. Correct? Likewise, the blender that you use that can blend what you give it, but it cannot do any other applications. Likewise, microcontroller boards have an ability to perform some specific application and that's it. And there's no more that microcontroller boards can do. And now let me tell you what are all the devices or what are all the components a microcontroller actually has. So if this is a microcontroller microcontroller, it consists of a CPU and also the memory. We know that it has RAM, random access memory, ROM, read-only memory, and also EEPROM, electronically erasable and programmable read-only memory. And it also has some input-output ports. It also has counters. It also has ADC, analog to digital converters, also DACs, digital to analog converters, and it also has timers on board and also counters, and it has so many in this way. So a microcontroller is a chip on which all the needed peripherals are being placed which help it to run a specific task. It is used to run a specific task that has onboard CPU and all the memory things or all the memory requirements and timers, counters, and it also has I want to count us twice. It's okay. It also has some communication protocols, communication peripherals we call it, like UART, SPI, and so on. So this is what a microcontroller board is. Remember, microcontroller is just like a brain to our body. It controls everything that's been happening in that particular project or the device. So now that we got to know what a microcontroller board is, now we have learned what a microcontroller is. Now let us see what a microcontroller board is. See, the microcontroller and the microcontroller board are not same. Microcontroller board is a board that hosts a microcontroller chip on it. For example, let me tell you, this is a microcontroller board, and on this board we have this chip which is a microcontroller chip. This is a microcontroller. Since we have this microcontroller on this board, we call this board as microcontroller board. This microcontroller has, let me show you. This is a microcontroller, right? So this microcontroller has all of these things. It has RAM, it has ROM, it has CPU, it has ADCs, it has DACs, timers, counters, etc. This particular chip. But this chip does not have any USB ports, does not have any voltage regulators, does not have any crystal oscillators, it does not have any peripherals such as the capacitors, the resistors, the buttons, GPIO pins. It all has to be put to it separately, and that is where we use this board. This board, which hosts the microcontroller chip and also some external peripherals to connect to some other devices, is called a microcontroller board. Got me? This is a microcontroller, and combinedly this board is called as microcontroller board. That is what the difference between a microcontroller and a microcontroller board. See, a microcontroller board is nothing but a microcontroller along with USB ports. This is a USB port. Voltage regulators. This is a voltage regulator. GPIOs, that means general purpose input output. These are all the general purpose input output pins. Communication interfaces, like it has receiver transmitter, which is UART protocol. It also has serial data and serial clock. And also some other communication interfaces like that. So this is what a microcontroller board is. Now let me tell you some examples for microcontroller boards, such as Arduino boards, ESP boards. ESP is also called as Espressif boards, STM32 boards, Raspberry Pi boards. We will briefly discuss about all these boards later in the session. So now, just to give you a brief, these are the boards, consider them as an example. Right. Now, what are the types that we have in our microcontroller boards? Let me show you each of those. First things first, I have categorized the types of boards into 3. I considered entry, intermediate and advanced level, so that you will get to know when to use a microcontroller board and what to use in some specific levels. So if you are an entry level programmer or entry level hobbyist who want to make some projects, you can go for Arduino Uno, Arduino Nano or Node MCU boards. Let me show you. This here is Arduino Uno board. Arduino is the company that produces these boards. Uno is the model name, right? So Arduino is the company that produces these boards, and Uno is the model number for this board. Model name for this board. And this is Arduino Uno, and this is Arduino Nano. You may compare the sizes. Arduino Uno, Arduino Nano, and it also has this one. This is called a microcontroller. When the microcontroller is combined with external peripherals, that is a microcontroller board. Okay, right. So yes, there are 2 kinds of chips here, right? See this one. This can actually be taken out and can be replaced if wanted. This is called DIP package, dual in package. Okay, the controllers or the microcontrollers that which you can take out and replace, they are called DIP, dual in packages. Whereas this board, we are unable to take it out by our own, correct? We need to desolder it using some specific mechanism, and these boards are called SMDs. These microcontrollers are called SMDs. SMD means surface mount device, that are mounted on this specific device, right? So these both are Arduino devices, Arduino Uno, Arduino Nano. And this one here is called Node MCU, or it's popularly known as ESP8266. ESP8266 or Node MCU. This is what the board is. This is mainly used for Wi-Fi applications. Whenever you need to involve or whenever you need to integrate Wi-Fi into your project, then you go for Node MCU or ESP8266 as a beginner. And now coming to intermediate level. In intermediate level, we have multiple microcontroller boards such as ESP32. Here you go. This is ESP32, which is also a product from ESP boards, Espressif company. Correct. So the difference between ESP32 and ESP8266 is ESP8266 is the predecessor of this one. That means this is the updated one, which has more processing power, more speed, and also more functionalities compared to this board. But comparatively, this board is cheaper than this one. And the additional functionality that we have in this ESP32 is the support to Bluetooth communication. This does not have Bluetooth communication but only Wi-Fi. This has both Wi-Fi and also the Bluetooth communication. And this is ESP32 and this is ESP8266. Right. So in this category we also have TNC 4.0, which is also microcontroller board, but it is way more faster compared to ESP32, and you may go for TNC 4.0 if you want to go for advanced level projects. And also Arduino Mega 2560, Arduino Uno, Nano and Arduino Mega. These three are the popular boards in Arduino company. Arduino Mega 2560 offers you with so many pins. It has around 56 digital pins so that you can control so many sensors. For this we have only 14 digital pins here. From 0 to 13 we have only 14 pins. So whenever you need to control some sensor, some actuators, or you need to connect some sensors, at that time you will need to connect to these. You will need to connect to these pins. Whereas if you have so many sensors to be connected to your microcontroller board, you cannot go for Arduino Uno because of the less number of pins. At that time you might choose Arduino Mega, which has so many pins to offer and you can connect so many devices. And coming to advanced levels, we have STM32 boards. STM32 boards are majorly used in industrial applications where there should be no delay. And also much of the accuracy needed. At that applications we use STM32 boards. Coming to Raspberry Pi Pico. This is the Raspberry Pi Pico board. See here, the Raspberry Pi Pico. This is also a microcontroller board. Unless all of these boards, this board needs the code to be written in Python programming language. And many of us think that Raspberry Pi is a microcontroller board. See, this is Raspberry Pi 3 model B I have in here. So this is a Raspberry Pi board. Raspberry Pi board is not a microcontroller board. This is a processor. See, microcontroller board can only do some one operation at a time. It is used to perform some specific operation. Unlike these microcontroller boards, this can also be called as a mini computer, because if you connect the Ethernet cable here, keyboard, mouse and monitor here, you can use it as similar to your CPU that you have at your homes connected to your desktop. This is so powerful that you cannot compare this board with all the other microcontroller boards. This is a processor that can also be referred to mini CPU. So Don't get confused. This is not a microcontroller board. This is a Raspberry Pi cam here. So we'll be doing so many projects with these boards later. But I just want to show you that this is not a microcontroller board. So that's the reason I'm not taking it into consideration. And we also have Arduino Uno R3 from official website. This is how it looks like. Arduino Uno R3 board. Yes. So coming to some other boards, like these are special boards I might consider. Lilypad boards. Lilypad is also from Arduino, but much of a smaller size, and that can be used in portable applications, and that is majorly used in medical applications. And coming to the last one, custom Atmega 3 to 8P ESP32 chip PCBs. For example, this is the PC. This is the board we have, right? But I don't want all of this board. So then what I'll do is I'll take a PCB of this such. This is called a PCB. This is called a 0 PCB, printed circuit board. I'll take this microcontroller and I'll put it on this, and I'll take some specific necessary components out of this and I'll solder along with this, and I'll use it in my specific application as I want. I need not to use this entire board, but I can use only this microcontroller and attach it to some other devices, and I can use it like that. And also this is called Atmega 3 to 8P microcontroller. This microcontroller name is Atmega 3 to 8P. You see here, Atmega 3 to 8P. This is Atmega 3 to 8P, and this here is ESP32. So if wanted, we can always take these two microcontrollers out and we can do our custom PCBs. Now coming to board selection criteria. That means how can you select which one is used for your project? For example, let me tell you, you want to design some project and you don't know which board to use. You can, at many cases, you can use any of the boards, but there comes some situations where you have to use some exact board to reduce the latency, or to reduce the size, or to reduce the cost. And that is where we get to the topic of board selection. See, whenever you are working on a project, you need to consider some specific criteria to your project. For example, I want to create a project based on patient health monitoring system. Like I want to create a fitness band, okay, a fitness band kind of thing to a patient to monitor patient vitals. There, the size of the board matters, because it has to be as small as possible, right? I cannot make it so large and I cannot make it so heavy. So there I'll consider less size, and also number of GPIO pins. That means general purpose input output pins. How many sensors are you actually connecting to that board? That means how many devices are you connecting to that microcontroller boards gives you the number of GPIO pins. If there are more number of devices that are being connected to microcontroller board, then you go for higher microcontroller boards which has more number of pins. Coming to connectivity, if you need wireless communication like Bluetooth or Wi-Fi, then you cannot use these boards, Arduino Nano, Arduino Uno boards. Yes, you can add some other chips to this like ESP8266 Wi-Fi chip or ESP01 to this, so that it may get connected to internet Wi-Fi, but that is not that recommendable. If you have such applications, it is advisable for you to use ESP32. If you are going to use Bluetooth or Wi-Fi communications, it is advised to use ESP8266 if you are going to use only Wi-Fi, since it is less cost. And now coming to processing speed, and all of these boards has their own processing speed based on the chips that we use in it. So if you want to use it for some specific applications such as image processing or some heavy applications, then these boards might not be suffice for you. Then you need to go for these boards, Raspberry Pi Pico and all of that. And coming to cost, if you want to make a project with low cost, you may consider using Arduino Nano ESP8266 or such, right? So coming to the use cases and some projects that we can make using these microcontroller boards. Coming to the first one, home automation. For example, you want the lights to be turned on automatically as soon as you enter into the room. You can use it for those projects. Weather monitoring system, for example, you want to monitor what the weather is out of your room wirelessly, and you want the data to be updated into some of the websites or something like that. Then you can use ESP32 or ESP8266 boards that can connect to the Wi-Fi to the internet, and they can transmit the data wirelessly from the sensors that you are using to monitor the weather outside. And coming to line follower robot. For example, line follower robot is a project that has some line and the robot follows that line, and you can make that project. Vehicle tracking system, you can get the location of a system, you can get the location of a vehicle using some devices like using GPS and transmitting the data from GPS through GSM to normal message, or you can also use IoT devices for that. Gesture controlled car, you want you built a car and you want to control that car using your hand gestures. That means if you tilt your hand to the front, it should move forward, backward, left and right. If you want to do something like that, that's where gesture control applications come into action. And face recognition system, you can also make smart locks systems using face recognition by using these Raspberry Pi boards. And coming to softwares, that means using which softwares that we actually program them. We know that these are the microcontroller boards and they are used to perform some specific applications. But wait, how is the code actually uploaded into this? How can we code this? And to code this, we use some specific cables which are called code dumping cables or programming cables. So for some microcontroller boards, we have some USB cables. Like for Arduino Uno, we have this. For ESP8266 node MCU or ESP32, we have this. And for Arduino Nano, we have this. Like that, we'll be having some specific data cables or the USB cables for some programming boards. Correct. So now using this, we'll connect this end of the cable to the CPU and we use these softwares to program these boards. Like we write some code in these applications of the softwares and we upload that code into these microcontroller boards using these data cables. And the most popular one is Arduino IDE, and the second one is Platform IO, which is an extension in VS Code editor. We use Thorny, UPyCraft, and these both are mainly used for Python programming in microcontroller boards. And the fourth one, STM32Cube IDE, that is used to program STM32 microcontroller boards which are used in industrial applications. Coming to the programming languages, we have C, C++. We use them basically in most of the microcontroller boards, such as Arduino boards, ESP boards, etc. And coming to Python, we use MicroPython to program the boards such as Raspberry Pi Pico, and we also use Python to code ESP8266, ESP32 sometimes. And coming to JavaScript, you may think that JavaScript is for web applications. Why do we need it in microcontroller boards? Remember, we can also host a website in this microcontroller board. Can you believe that? We can actually do that. We can host a web server in this microcontroller board, and to write those we use JavaScript. Coming to assembly language we use to program STM32 boards. Coming to block based programming, that means we have to write some lines of codes to write program to these microcontroller boards, right? uh, Unlike that, we have some blocks in these programming softwares, like we have to take some blocks and place it in the workspace so that it does some code for us. For example, like there are some softwares like Scratch, Tinkercad, and we also have Autoblockly softwares that are basically block based programming softwares. And this is pretty much about microcontroller boards. No one can become an expert overnight, right? So pick a board of your choice and go do it. I'll recommend starting with Arduino Uno board. Go get yourself an Arduino Uno board and start with blinking an LED program, and there you go, and that's what your first program will be, and that's where you will start your electronics or programming journey with. Ask me if you have doubts any, and thank you.